Hey, what's up, Chem Peeps? What in the heck are we gonna do in this vid? We are going to use the activity series to determine if a given reaction will occur. As always, breaking it down, we are going to 1. Explain the significance of an activity series. The heck is it? How is it gonna help us? Dos. We are going to use an activity series to predict whether a given single replacement reaction will occur. Finally, number 3. We're going to predict the products of a single replacement reaction. Alright, so first thing first, what the heck is an activity series? It's just a list of elements that are organized according to the ease with which those elements undergo certain chemical reactions. And it's really useful to help us predict whether or not a chemical reaction will occur. So here's an example of an activity series of metals. We're just organizing the metals in terms of reactivity. And here's another activity series for the nonmetals. Again, just a list to help us recognize the ease with which these elements will undergo certain chemical reactions. All right, so let's start with the metals. Your metal activity series is going to organize your metals in terms of their ease to lose electrons and form positive ions. So as you take a look at this activity series, the metal that is going to lose its electrons most easily is lithium. And on this list, the element that's least likely to lose its electrons and form an ion, a positive ion, is gold. Now, notice the activity series that you're provided with corresponds to an oxidation potential chart. Remember, the process of losing electrons is known as oxidation. And what this has done is set an activity series next to an oxidation potential chart. So you're also provided with the numerical value to help you quantitatively compare the ease with which one metal loses electrons to another. Now notice hydrogen, a nonmetal, is on this list. Hydrogen is sort of our reference or starting point. The ability for these metals to lose electrons is compared to hydrogen's ability to lose electrons. That's just the element we decided as a reference. Notice there are some metals that lose electrons more easily than hydrogen, and there are some metals that are less likely to lose their electrons than hydrogen. Same thing applies to nonmetals. We can create an activity series for nonmetals, except recognize here we're talking about gaining of electrons. And so the activity series here is organizing them in terms of ability to gain electrons and form negative ions. So take a look at your activity series for the nonmetals. Notice this time that you're provided with your activity series sort of juxtaposed with a reduction potential list. Again, hydrogen is sort of our reference point. We're comparing how easy is it for these nonmetals to gain electrons compared to hydrogen. So once again, hydrogen is our reference or our starting point. Couple things to know about these activity series. Recognize the most active element is placed at the top of the series, and that element can replace each of the elements below it in a compound in a single replacement reaction. So, as you take a look at the activity series for metals, lithium is the most active, most reactive metal, and it can replace any of those other elements in a compound. Now, if you're not working with that element that's at the top, any element that's further down the list can replace any element below it in a compound, but not above it. So if we were, for example, talking about calcium could replace any of these elements in a compound, but not any of these. All right, let's take a look at a thriller of a simulation to help you better understand this idea of an activity series and how you can use it to help identify whether or not a single replacement reaction is going to occur. We're going to start with some solid copper and a solution of silver nitrate. Look at your activity series and compare where does copper fall on the list compared to silver. Is a reaction going to occur? Is copper more likely to lose its electrons? Is copper more likely to be oxidized than silver? Let's find out. Placing that copper in the solution. Zooming in to the molecular level to get a better vantage point of what's going on. Zoomed in. Let's observe what happens. Is copper going to replace silver in solution in that compound? You betcha. It's more active. It's more likely to lose its electrons than silver is. And so notice that copper is going to replace silver in the compound, sort of pulling the silver out and taking its place. Boom. Copper, more likely to lose its electrons than silver. Another way to think about this, silver is more likely to gain electrons than copper. But we'll talk about that later. Notice at the macroscopic level, your copper strip has begun to dissolve as that copper loses electrons and float into solution as copper ion. And the silver has sort of played out, fallen out of solution as it got kicked to the curb by copper. That does it for this vid. Have a fantastic day.